So in this video, we're going to be looking at the epoxide opening in acidic condition. Again, considering first the regioselectivity. So same solvent as the basic condition with methanol, now switching the catalyst with hydroboric acid, typical representative of an acid. Under these conditions, one might suggest, why is not the ethanol adding directly on the epoxide? The answer to that, methanol is a neutral nucleophile, weak nucleophile. The epoxide is neutral too. This reaction is slow, not significant, okay, in the mechanism of the reaction. So what would happen instead? We're going to have the activation of the epoxide by the acid with protonation. So electron-rich oxygen can grab the proton, forming the protonated epoxide. Here on purpose, I didn't show any stereochemistry. We're focusing on the regioselectivity of the reaction. We'll do the stereoselectivity later. Now the epoxide being protonated is highly electrophilic and will be attacked by the methanol. So the attack of the methanol, a little bit like we saw in basic condition, can proceed in two different ways. We can have addition on the least substituted carbon, shown with the purple arrow, or we can have addition on the most substituted carbon, shown with the green arrow. So that's going to give us two possible intermediate. Okay. So let's show both. So these will entail the opening of the epoxide, that I haven't shown, but that I'll show, two irreversible reaction. So let's start with the purple one. Okay. So if the methanol adds on this carbon, we're going to break this carbon-oxygen bond. That would form an intermediate like this. So the methyl group stays on the same. We're going to have an OH here. And what we now have appearing on this carbon is the methanol. So OH with a positive charge with a CH3. So that is one first intermediate. The other intermediate, possible if the methanol add on the other carbon here with cleavage of this carbon-oxygen bond. So we're going to have here a similar intermediate. So the methyl group is not changing position. The methanol is adding at that position, so that form OCH3. It's the methanol that adds, so it keeps the hydrogen with a positive charge on the oxygen. And finally, we have cleavage. That's the green arrow here, showing that there's an alcohol form here. So these are the two intermediate that will lose a proton, more or less reversibly. So the proton can be lost to a bromide, or can be lost to another alcohol molecule, or to the epoxide. We don't have to show specifically what's grabbing the proton. Proton is lost. The electron goes on the oxygen. That's always what we show in the mechanism. And we get the two possible product, the OH and the OCH3. And similar here, but on different position, OCH3 methyl and OH. Now, which of the two product is the major product? Again, that's going to be decided in the irreversible step of the reaction. Okay, so the regioselectivity will be decided about what is favorable. Okay. So we have again here two possible carbon. So we have a secondary carbon here with two alkyl groups, and on the other side we have a tertiary carbon. But in this case, what dictates the reaction is not how easy the methanol is adding, Because there's already a positive charge. Okay, so there's another variable more important. You saw this in organic 1 under the SN1 umbrella, okay, or SN1 type mechanism. So because there is a positive charge on the oxygen here, and after this step the positive charge is changing oxygen, in between the positive charge is going to be on one of these two carbon. In the purple mechanism, the positive charge will resemble the secondary carbocation. So we're going to have a partial positive charge on the secondary carbon. That is actually a transition state. In the green mechanism, okay, addition of the methanol on this carbon, we're now going to have a partial positive charge, delta plus, or plus delta, on a tertiary carbon. So in acidic condition, the regioselectivity is decided by the nature of the transition state. Secondary versus tertiary transition state. Which of the two is more stable? That will be the tertiary carbocation. So that's why what is observed is that the major product, not the minor, the major product in the reaction is the one derived from the methanol adding on the most substituted position, so that's major, and that will be the minor. I said product, strictly speaking that's inappropriate because these are intermediate, but that's transfer into the product. So the real product is the neutral hydroxy ether. So under these conditions, the reaction is under SN1 type control. The other way to name that is say that it's under electronic control. What is important is that the initial charge form on the oxygen is present in the transition state, influences the outcome of the reaction. So that's why we say under electronic control. Therefore, the reaction is on the most substituted carbon because it gives the most stable transition state. That's it. So in the next video, we'll look at the stereoselectivity of this reaction.